Just in context, this is the proposed layout for a project that is still under design. As you can see, it is a fairly big project, and the water source for this project is this reservoir here. As you can see, we have a reservoir here, and we want to install a pump around this area in which we are going to pump water from this location all the way to this point here. Okay, so this is a hill, and this is a point where our main tank is located. So our duty today is not to design the whole project, but rather to design the rising main for this project. Okay, so for now we have this just a rising main. So for now we have our network ready, and what we need to do now is to start the actual design, of course in WaterGEMS. But before we even shift to the actual design, we have two steps. The first step is how to extract. Let's say we need to extract our coordinates from the KML files, and to make sure that we have the UTM coordinates, of course in Excel format. And the second step is to make sure that we use the extracted coordinates, of course in Excel now, and import that coordinates in WaterGEMS, so as we can start the actual design. But for the sake of time, we're not going to do those two steps. But if you want to learn how to extract data, let's say from KML files, and how to import the extracted coordinates, of course from Excel to WaterGEMS, I'll make sure that I include two tutorials that will help you to achieve that in the description below, or in the first comment below. So without further ado, why don't we start with the actual design, of course in WaterGEMS. So for now, we have our model in WaterGEMS already. And before we do anything, as a rule of thumb, we need to make sure that we have settings that we need for our project. And for my case, I'll just go straight to home, and if I select options, you can see I am provided with this pop-up window. Now, what I need to do from here is just to right click and select properties. You can see we have some few options here, but for my case, I just want to make sure that the Hazen-Williams head loss formula is selected. And also, I want to make sure that I am only dealing with hydraulics only. Of course, it's not important, but hey. And also, you can see the engine compatibility. For now, I want to use the WaterGEMS. So instead of Ethernet, I'll just use WaterGEMS. I don't think if there is anything that I can do from here. Let me go straight to Tools to see if there is anything that I can do from here. Now, if I go to Tools and I select this one, I select this option here, this is the window that I'm going to be provided with. Now from here, what I can do is to select units. As you can see, we have a lot of units here, of course parameters units that you can change, but for now I don't think if there is anything I can change from here. Maybe I'll come back to this window later, but the only thing that I want to make sure that is if, for example, I want to use, so for my case, I want to use the ACI unit. And if you want to use the ACI unit just like me, then select this option here. Otherwise, you can even go with US customary units. But for me, let me stick with the ACI units. Remember, our project is a pumping water project. And as of now, we don't have any pump here. Now, what we need to do is to make sure that we introduce a reservoir, and we also introduce the pump, because these are the two parameters, WaterGEMS parameters, that will help us or will assist us to model our pump or to design our pump. Why don't we jump to Ethernet and see, and let me show you how we can do that. What we need to do from here is to introduce the pump. Of course, just like I said, to introduce a pump. Now to do that, we have two options. We can even go with the layout tab, and also we can also select this one. So let me select this one first. If I click this layout, what I can do around this area here, let me write. So for now, you can see junction is active, but I don't want to introduce the junction, but rather what I want to do is to introduce the reservoir. Now to achieve that, I have to right click. From here, I have to right click anywhere. You can see we have these options. I want to select the reservoir, then I'll just click somewhere here. Then again, I will right click again, and I'll select the pump. Where is the pump? Pump. Yeah, this one. So I have to click somewhere here, and I'll link the pump with this junction here. So this is the junction where our pump is located on the ground. So I'll just right click and I'll select junction again. Then I'll come to click somewhere here. Now from here, I'll just click done. Again, done. So as you can see, for now, we have managed to introduce the reservoir and to introduce the pump, of course, in our network. Now, what we need to do before we even do anything, Remember, when we are dealing with pump, the first thing that we need to model any pump or to size any pump is the pump curve. And before we even do that, I will need also to introduce the elevation data for the reservoir and the pump. Remember, the elevation data for reservoir and the pump will be the same as elevation data at the junction J11, actually J12, okay, J12, because this is the junction where our pump will be installed in the real world, so to say. To do that, let me go straight to the software and I'll show you how we can do that. First thing that we need to do is to make sure that the elevation data at junction 12, which is located around this area where we have our collection sump, should be the same as elevation data for our pump and also the same for elevation data for this reservoir. Okay, so if I double click this, and I'll just copy this elevation value for this junction J12, I'll copy it and I'll just open. So if I double click for the pump, if I double click this for elevation data, I'll need to paste the same value. And also for this one as well, I will need to paste the elevation value. So here I'll just need to paste the elevation values and I'll click close. So now that we have the elevation data for the reservoir and the pump, what we need to do next, as I told you, is there's no way you're going to size this pump if you don't have the pump curve. Remember, this is a centrifugal pump and any centrifugal pump operates within a given pump curve. So for our case, we are going to introduce a pump curve right now. So let's see how we can do that. Okay, so to introduce a pump for this, to introduce a pump curve for this pump, we have to approach. The first one here is to double click this one. And again, you can just go and select pump definition. Where is pump definition? So this one. And the second approach is to go straight to this area. So to go straight to home, then you select the pump definitions. Okay, I'll just select this pump definitions. Of course, this is the second approach. I had this pump curve here, but I'm not going to use this, but rather I'll introduce a new pump curve and I'll just name it. Of course, just give it a name. Let's say pump number 1. Okay, so as for now, you can see we don't have anything here. We don't have anything. And if I take you around this area, you can see we have several approaches. And for our case, what we are going to use is the design point of course, this option here. So if I double click my pump curve 1 again, and if I select a single point, you can see for now we have only this design point. But for now, we don't know the flow for this pump. Okay, we don't know the flow. Okay, so at this point, WaterGEMS asks us to provide 2 parameters. The first one is flow and the second one is head. Okay, so let me start with flow. According to the water demand estimation for this project, we need to extract 9.41, okay, 9.41 liters per second from this reservoir. And this is going to be our design flow for this pump. So in other words, we need a pump that will be able to deliver 4.1 liters per second. Okay, so from this reservoir all the way to our main tank. And for head, when it comes to head, we have several approaches, but for our case, we are going to use the trial and error approach. And what we'll do is we'll provide multiple heads just to make sure that the best head will be the head at which our pump will be able to deliver the said water demand, which is, for our case, was 9.41 liters per second. So let me show you how we can use this trial and error approach to make sure that we have the required pump for our project. Okay, so as I said, according to water demand analysis, which is actually this one, the total water requirement was 9.41 liters per second. So I'm going to introduce here 9.41 liters per second. And for head, because as I said, we are going to use trial and error. So the first guess is going to be the static head. And if I close this, you can tell the elevation at this point here where our pump is located, which was this one here. The elevation at this point here was this value. So if I take this value, if I copy this value, and actually paste it somewhere here, Okay, so if I go back to where our final point is located, which was this one, the elevation at this point here was this value. So if I copy this value and I paste somewhere here, okay, so I want to find the static head. So if I take this value, if I less this one, you can see we have this. So this is the static head. So this is the static head between our storage tank and our location where our pump will be installed. So for our case, the value here is 116.3 meters. And again, if I go back to pump definition, I'm going to provide the same value, 116.3. As I said, this is the static head. Of course, this is our first guess. Now from here, what I need to do, now from this head here, if I go to efficiency, I'll just provide the BEP flow. Of course, at this point, I need to provide our design flow, which was 9.41. If I click OK, you can see we have this kind of shape. And if I go back again to head, okay, so that's it. So if I close and if I validate my model again before I run, you can see we are still having some issues. Okay, if I click OK. Okay, so pump definition is not defined. So okay, so what happened is that we have created our pump curve, but we haven't assigned that pump curve to our pump. So that is what we are going to do next. Now to assign the created pump curve in our pump, what we need to do is to actually double click this pump here. And again, I need to provide where is the pump definition? I need to find where the pump definition is. Okay, so this is the pump definition. If I select pump definition and if I click this drop down menu, you can see we have our pump curve, which was pump_1. As soon as I selected it, you can see we are having this kind of data populated or extracted from this pump curve that we created earlier. Now, if I close this and if I validate again, you can see for now we don't have any issue. But does that mean that everything is okay? Of course not. Not everything is not okay. Now, what we need to do is to find a way where we can optimize our design. And this is exactly what we are going to do next. Okay, so from here, what I need to do is to actually run my model, because if I validate again, you can see no error. Now I need to compute my model. Okay, as you can see for now, it seems as though we are still having some issues because you can see we have 2 trials, but the flow is 0. So flow demanded is 0, flow stored is 0, flow supplied is also 0. If I go back to pump definition again, I needed to have at least a flow, but for now we are having 0. Okay, so let me display. So let me go to this point here and introduce annotation. So for annotation, I need to display the flow values. So for results, I need to display for flow values. And you can see for now, flow values are not visible. I want to push them in Y direction, to offset them in Y direction, of course, with -2. But again, we are having 0 as discharge. Okay, it seems as though we are having some issues here, because if you can tell for now, so this part of the network is not connected to this part. So we need to find a way where we can join this junction 2 to this junction 13, because for now it's like our network is disconnected. Actually, this is the reason why we had such an error. Now, what I need to do, let me delete this. I need to delete this, then to introduce another. Then I will introduce another pipe, actually, another link. I am used to link, actually. Link is used in Ethernet. Okay, nevertheless. So from here, what I need to do is to double click this. I don't think if there's anything that I can change here. So the pipe lengths are the same as what we had before. So if I run my model again, at least for now, we are having that the flow supplied is around 8.51, actually 8.56. Then the stored value is again the same. So for now, at least we are having a good results. Now that our pump is connected to this storage tank, we can see we have amount of water that is stored at this storage tank here. Now, before I even move further, let me close this first. And again, let me close, if I go back to pipe at this area here, let me close this label. You can see for now, I want to display only label. Okay, so even for junction, I don't want to. Okay, so now we have this. We have this kind of. And what else? Okay, so this is what we have. If I run my model again, you can see we are having here like a negative pressure in our system. Let's see what we can have. Because this is the flow. Now let me introduce another parameter, which is unit head loss or head loss gradient. If I go to results and if I select head loss gradient, where is head loss gradient? Yeah, this one. And I also need to offset this in X direction. So in X direction with -2 as well, the same value. It seems as though it's not working. So -2, again, let me introduce -4 in Y there. Actually, it's not in X direction, put here 0. Now in Y direction, let me go with +2. Okay, but as you can see for now, the unit for this value for head loss gradient is meter per meter. Okay, this is just not what we want. And you can change this with two approaches. You can even go here to tools, but the way I prefer to do it is to click any link. Then I need to find the head loss gradient. Where is head loss gradient? Okay, so head loss gradient is this. So if I right click this and select unity and formats, you can see we are having here, so for units we have meters per meters, but that is not what we want. I want meters per kilometer. And with display precision, actually 3 is too much. Let me go with 2. Then, okay. So for now, we are having 1.26 meters per kilometers. This is way too much. We don't want this. And again, if I display, let's say velocity, so for pipes, if I display velocity, so for annotation, if I display velocity, where is velocity? This one. I want to display velocity. So if I click apply, again, this is not very good. Let me push this value in -2. Of course, let me offset this value -2 in Y direction. And if I apply again and I close this, let me close flow. You can see velocity is actually not that bad, 0.43, because it is somehow greater than 0.4. But this is just not sufficient because our flow here is actually 8.56, which is not the flow that we want, because according to our water demand analysis, the figure that we want here is 9.41. Now, what we can do is at least to find something else. So if I go back to the pump and if I double click this, and if I go to pump definition, and if I select edit pump definition, and if I select our pump definition, which was pump 1, I will need to increase this a little bit. Let's say from 116 all the way to 1125 and see what 125 and see what we are having. So if I close again, and if I close this, and if I run my model again, if I compute my model again, you can see we're still having some negative values. But for now, we have a good sign that we have our flow, which is 9.54, which is somehow close to the figure that we wanted, which is 9.41. So this is not very bad. I need to display velocity for these ones, because as of now, you can see these two pipes, so this one here and this one, they are not part of this network. But as you can see here, they are contributing head losses to our system. That is something that we don't want. So as I said, these two pipes, they are not part of our network. And what I need to do is to find a way to make sure that I design my network in such a way, these two pipes, they have zero contribution. Of course, when it comes to head losses, zero contribution to our network. And to achieve that, what we want to do is to make sure that the pipe length is too minimal and the pipe diameter is very large. Now, if we do that, we'll be very sure that no head losses from these two pipes will be contributed or taken into account in our design. And for just a very obvious reason, because we don't want the head losses from these two pipes to be taken into account in our system, because these two pipes, they are not in our system, but rather we introduce them just for one reason, to link our reservoir and our pump. Okay, but they are not part of our network. So let me show you how we can do that. To do that, I have to double click this, and also you can even go to a flex table. So if I select flex table, you can see those are the two pipes, but I want to use this approach actually. So this is the diameter. I want to make sure that we have a very big value, and also for the length, we need to make sure that the length is too minimal. So let's say 0.5 meter or 0.05, which is very, very small. And again, we want to do the same for this pipe here. And again, we need to specify the diameter. Just, of course, as I've said, to make sure that these two pipes has a zero influence in our design, because these two pipes are not part of our network. So the diameter, so the length here is 0.02, just that minimum value. And again, if I run again, you can see for now the unit head losses here are zero. Okay, at zero. Now from here, what I need to do, let's see if there is anything that I can do. Okay, so the velocity for these pipes here, so is 0.48, and again for this part here, velocity again is 0.48, and again the same value for this one here, 0.48. And if I select, let's say, unit head loss gradient, you can see we have 1.55, of course, meters per kilometer. And again, but for these two pipes, you can see the unit head losses here, or the gradient, the head loss gradient is zero, which again, that's what we wanted, because we don't want any contribution from these two pipes in our network. So as I said, this is the results that I need for my network, because if I check, I take a look at the velocity, we're having 0.48, and again the flow is 9.54, which is somehow close to the flow that I needed according to the water demand that is required for our pump, which is 9.41. Now from here, what I can do is to make sure that I determine the required pump. Okay, so after everything, we also need to answer the question of what pump do we need for this, what pump capacity do we need for this network, and this is what we are going to do next. Now, to get the required pump according to this kind of network, what I need to do is to go to this tab which is written report. If I select this, and if I select pump, and if I display pump, you can see we are having this kind of window. So our pump is located at this elevation, and again, this is its pump curve, and again we have the initial status. And for this area here, you can see for this area we are having the total flow, which is 9.58, and again the pump head, the total pumping head for this pump is equal to be 123.5 meters. So just in nutshell, for this kind of network pump that is required, first it needs to have a flow of again 9.41 or 9.48, and again it also needs to have a total pumping head of not less than 123. So that is what I wanted to share with you guys. If you're new here, forget not to subscribe, and if you get value out of this video, forget not to like and also to share it with your friend. Until next time, have a good day.